Graphing sine and cosine becomes much harder when we have phase shifts. So here we have a phase shift based off of pi over 3 and theta over 4. Specifically, our phase shift is negative c over b, which is negative pi over 3 divided by 1/4, or negative 4 pi over 3. Also, our period is 2 pi over that 1/4. So 8 pi is the period. We actually don't even have full 8 pi, so we're not going to get a full period of sine. This is going to be a very wide graph. Not many cycles, less than a full cycle on this graph. In order to successfully complete this, the easiest thing to do in my mind is to try to think of when is this going to be 0. If we set that whole input equal to 0, we get theta over 4 plus pi over 3, subtract pi over 3, equals theta over 4, multiplied by 4. You get the phase shift. That's why c over b is the phase shift. So negative 4/3 pi is going to be a little bit over here. I guess I could move this graph over and then say that it's going to be, okay, here's pi over 2, here's negative pi, here's negative 3 pi over 4. It's going to be somewhere around here is that. Now we've been shifted down 1, and so our equilibrium is at negative 1. And we're going to be going up here and up to positive 1 and down to negative 3. Where's the next place where we're going to have an equilibrium? Well, if we add 4 pi, that'll be half of a period. So this is it might be easier to write this as negative 1/3 pi. If we add 4 pi to it, then we get to 2 2/3 pi, which will be our next equilibrium point. So 2 2/3 pi. And then if we add another 4 to that, we'll get to, I'm going to erase this work. We're going to get to, let's see, this would be 6 2/3 pi would be our next equilibrium point. So all of the equilibrium points are half a period apart, because there's multiple times that it hits the equilibrium at the beginning, at the end, and then halfway between. So now the maximum values are halfway between each of these. So here were our 3 equilibrium points. And then if we go halfway between here and here, so that's like halfway between here and here is 4 2/3 pi. That would be here. This is going to be where we have a minimum value. And then halfway between negative 1 1/3 and 2 2/3 is 2/3 pi. So that's where we're going to have a maximum. So overall, our sine curve is going to look like this. It's kind of difficult to make this look smooth, but that is going to be our sine curve. Again, once again, what we did was we shifted it down 1, we stretched it with an amplitude of 2, shifted it left by 4/3 pi, and then we have to expand it over a whole period. Because the period was 8 pi, I knew that it would return back to 8 pi, or 8 pi later. So that's why I knew 6 2/3 pi worked over here by adding 8 pi to our phase shift. And half of that was where the other equilibrium point is. The maximum is halfway between the first equilibrium and the second equilibrium, and then the minimum is between the second and the third equilibria. Here's another example. We have a phase shift up this time. So here's going to be our equilibrium line. We have no amplitude shift, so it's going to be just between 0 and 2, so the range is from 0 to 2. Let's find the phase shift. It's going to be negative pi over 2 divided by 3, which is negative pi over 6. So somewhere around here, but it's cosine, so we're starting at a maximum. And lastly, we have as our period, the period is 2 pi divided by b, so 2/3 pi. So if we go another 2/3 pi, you might not be able to do this in your head, what negative pi over 6 plus 2/3 pi is, but if we repeatedly add 2/3 pi, we get, I believe it's going to be 1/2 pi is the next place where this repeats. So this should be a whole cycle from negative pi over 6 to here, because these are 2/3 pi apart. Then I can go another 2/3 pi apart over here, and then another 2/3 pi apart over here. It's hard to add 2/3 pi in your head. So let's see. If I add 2/3 pi, this would be 3/6 and 4/6, so 7/6 pi. And then if I add another 2/3 pi, then we get to 11/6 pi. Yes. So 11/6 pi is 11/6 pi is almost to 2 pi is 1/6 before 2 pi. So okay, so here are our 3 times that it repeats. So there should be a whole cycle between here and here. Halfway between these two is going to be a minimum. Halfway between these maxima, there should be a minimum. Halfway between these maxima, there should be a minimum. And then halfway between each maximum and minimum, there is an equilibrium point. So now it becomes clear how to fill in the rest of our graph. Once again, what I'm using is I'm using a period to figure out how far you have to go to get to the next maximum point. And then once you have all of the maximum points, you can go halfway left-right to find where the minimum points are. Or you could say, instead of add 2 pi over 3, if you add pi over 3, that's this distance here, because that's half a period. And then add another pi over 3. Or if you wanted to find where each equilibrium point is, you could divide it by 4 and say we're doing pi over 6 to go right, pi over 6, 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 pi over 6. Each time we go right pi over 6, we're switching from maximum to equilibrium to minimum to equilibrium to maximum, etc. So this is how you graph things, sine and cosine graphs with phase shifts. Determine the equilibrium line, find the phase shift in the period. If it's cosine, find where each of the maxima occur. If it's sine, find where each of the equilibrium points occur, and then space out the other points appropriately.